That number is now wildly out of date.
You know, you've no idea what you're setting out to find, but you're looking for something.
You are my brother.
One of the most popular videos on the We the Curious YouTube channel is an incredible 360-degree animated video of real exoplanets. Over the past 7 years, we have been overwhelmed by all the comments you've left us on this video. Exoplanets are planets that orbit stars other than our sun. This video was created by actual exoplanet scientists at Exeter University. But science is always on the move. And so we've returned to Exeter University to ask the scientists there to watch this video again and give us their reaction today.
I love this bit at the beginning, where you see just the immense number of stars. I mean, it does make you feel kind of tiny, and our solar system is just a dot, you know?
So the planets will form over maybe 4 or 5 million years as the star forms.
So the first thing we see is a young forming planet. This is a planet that's, well, it's actually formed just recently, and it's still got all the material left around it. I guess one of the questions that comes to mind as we watch the video is, why would we want to learn about these planets?
The real reason we do these things is because we find it tremendously exciting. We think it's an adventure. That's why researchers do research. We're basically big kids. But doing fundamental research has serious real-world benefits.
Learning about other planets gives us an insight into how planetary atmospheres and climates work. You're seeing things right at the sort of extremes. And that knowledge actually helps you understand how our own planet and climate will evolve.
You know, this is an imaginative impression of it, but actually we do know that they look like this. I mean, we have telescopes, we can see.
And it's nice to see them as they form. Obviously, I wish we could see them this clearly. That would be really great.
You can just start with dust and end up with something bigger than Jupiter. It's kind of incredible. And the fact that we know that and we know how that happened.
You know, a lot of what we, I guess, discuss about exoplanets, a lot of that for a long time has been theory. You know, things have changed even since this first video was made. You know, we've had the James Webb Space Telescope launch, and so we're not only discovering more exoplanets, but discovering more about them, which is very exciting. It makes me wonder about what our solar system was like, you know, millions to billions of years ago. You know, back in the day, maybe Venus was quite a nice place to be.
We're going to hopefully at some point in the future have better observations and be able to test the predictions we make. The interesting thing happens when you're wrong, and then when you're wrong, that's the moment you learn something.
Well, hot Jupiters are gas giant exoplanets, but they orbit much, much closer to its star than Jupiter does to our own sun.
This is WASP 121b. This planet is so close to its parent star that it's literally being sort of boiled off, the atmosphere is. This planet has been studied intensely with the new observing facility. James Webb Space Telescope was launched just recently. And what's great about that is it's been able to bring our knowledge on quite significantly. Why do we know this planet is really close to its star, and how do we know it's getting boiled off? Well, the first thing we can do is watch as the planet moves in front of the star. Really simple, and it just blocks out some of the light. And from that, you can work out the radius of the planet, how much light gets blocked out. Also, you can look at the light that's kind of filtering through the atmosphere, and that, with it, gives you information of what's inside the atmosphere as well.
So what we're looking at is planet Osiris, otherwise known as HD 209458b, and these are extremely strong winds.
I also love this bit where he says, this is the planet, short name, and then lists a bunch of letters and numbers.
Planets like this that you can model pushes the limit of how we model the Earth. And the models that we build to forecast the weather and to forecast the climate, we can really put them through their paces and test them and improve them by trying to model planets like this. We can use these models and produce, you know, ideas for actually how quick this wind is. 5 kilometers per second. And we know that. It's brilliant.
In our own solar system, we have no planets which exist in the size range between Earth and Neptune, but actually as we observe off into the galaxy, we find this is one of the most common form of planets. And this is a water world. This one always makes me feel sick and anxious, actually. So these planets are called super-Earths, and they're much larger than the Earth, but we still think they're probably terrestrial. They probably have like a rocky surface and a big atmosphere. We don't know for sure, but there's some good reasons why they might be sort of covered in water. Things like they have a much higher gravity, so as you're trying to form mountains from tectonic plates, that's much harder. There has been some work recently though, using again the James Webb Space Telescope, where there's been some detections of potential water in the atmosphere of these planets. So potentially they could be ocean worlds, but we don't know.
And yeah, the water world, this is brilliant. It's like interstellar, these massive waves. That's pretty bonkers. One of the things that they say here is that one of the reasons for these massive waves is there's no shore to hit and break up some of that energy. And you never really think about that when you're thinking about Earth itself and the dynamics here.
So this planet is incredibly hot and has a very strong gravitational field. So what you can see is a molten lava field underneath you. Okay, so this is one of my favourites. We had so much fun working with the team at Engine House, who were the visual effects designers for this. This is as close to you can get in the known universe, I guess, to hell. Yes,
55 Cancreti. I can't watch this bit without thinking of Ewan McGregor's voice. You are my brother.
This planet here is really, really hot. And so to me, I've mostly been focused on cooler planets. And I guess it's cooler planets where you think, it might be biased, but where you think where more interesting things happen in terms of the sorts of chemistry and potentially biology can happen. But we're always being surprised by nature. So we don't by any means know what we're going to find.
TRAPPIST-1e is a fascinating system. It was a wonderful surprise to find 7 fairly Earth-sized planets so closely spaced together around this tiny star. The star is actually about the size of Jupiter. It's really like a solar system in miniature.
We have TRAPPIST-1e here. A lot of these exoplanets are named based on the survey that first observed them. So TRAPPIST is another telescope that was used, named after the beer, I think, Trappist beer, which is then named after a monastery. This would be the best picnic place, I think. You've got some rocks you can climb, you've got sand. It's not quite a beach because there's no sea to paddle in, and the sky looks great. I mean, you've got this aurora effect again, charged particles in the atmosphere. That's probably the one I'd want to holiday on the most.
It looks very Earth-like. So could this be a clue to what Earth was like back then, or what it might evolve to be like? And I think if I were to go to any exoplanet, I would probably go to one that is as similar to Earth as I can get, because I would love to see what life has developed like elsewhere.
I always like getting those points of view that I think you can look inward better when you're looking outward. One of the big pluses, I think, to astrophysics and looking at other stars and other planets, making these educated guesses about what things are like, helps us still make our own educated guesses about Earth and dynamics on Earth.
We study exoplanets because we learn a whole lot more about Earth doing it, but there's also just an element of curiosity and kind of fascination that we want to explore and we want to understand and we want to know what else is out there or who else is out there. It's kind of, I suppose, the 21st century way that people and philosophers and thinkers have been looking for years and years about a sense of meaning or belonging. Or it's the modern version of setting off on a ship and finding a new continent. It's us wanting to see what else is out there, and if we can find out answers to the questions that humans have been wondering about since forever.
Doing research into really alien worlds is really useful, because the point is that there's all this knowledge that we've built up over centuries that explains, or we think it explains, the world that we've seen so far, the universe we've seen so far. But actually, at some point, at least some of that's going to be overthrown by some new experiments or some new observations that we make. We might find out about something that's like electricity that allows us to do something new and exciting, will make people's lives better in some way.
We have discovered over 3,000 exoplanets.
That number is now wildly out of date. 3,000 exoplanets. We have more like 6,000 now, and in fact 6,000 is the number of confirmed exoplanets. We have many more, tens of thousands, which are very strong candidates, but we haven't checked them, and there's still lots more to discover.
Each new planet we discover changes how we view the universe and our place within it. But so far, we've only found one, planet Earth.
There are missions in the future which are designed to try and look more at terrestrial planets, to try and search for signatures of life.
It's such an exciting field because of how quickly it progresses and how much we can learn.
I watch a lot of sci-fi, and we have this kind of image of humanoid aliens, but actually is it just kind of weird looking bugs, or is it odd fish in these kind of ocean planets? Yeah, that's what excites me, I think.
It's really probably just a flavour of all the different kind of exoplanets that are out there. I find that really fascinating. The idea that you can imagine a planet like something from science fiction, and then actually, well, maybe it exists, or maybe something even wilder exists.
What do you think? Have the Exeter team answered any questions you might have had? Have they given you more questions to think about? And if you could visit any exoplanet in the universe, what kind of exoplanet would you want to visit? Let us know in the comments, and don't forget to click like and subscribe.